Go.
In Unit 2 of Gears and Drivetrain, our objective was to identify the different types of gears, explain the difference between speed, power, and torque, demonstrate the correct use of calculations needed to choose a gear reduction, describe the relationship between radius, diameter, circumference, revolutions, and distance for a wheel, open and download sample code to that robot, analyze the features of that robot, and graph the results. In our project, we had to create 3 iterations of our robot drivetrain and experience how gear reduction affects distance traveled. And this is the robot, and Hayden is going to tell you about it.
Our robot was built with 4-inch traction wheels because the traction wheels help with the friction on the floor. They're not as slippery as the rest of the wheels. We use spur gears because those are the easiest gears to use. And we have everything in the middle of it because it helps center out the weight of the entire robot.
Okay, and Jack is going to tell y'all about the code for the robot.
So right here, we have our motors set for motor port 1 and motor port 10. And we have the velocity set at 50%. We're having it spin forward for 3 seconds, and then they're gonna stop after they reach 3 seconds.
And now we're going to go to the robot and run it.
You can talk about the math.
As you can see, our robot did exactly what it was supposed to do. In our data, we predicted it to go 62.98 inches and it went 64.75. That means that our percent error was only 2.8, which is really good. To calculate our actual, our percent error, we did actual minus predicted divided by actual times 100, and that's how we got 2.8.
All right, Hayden, why did y'all use the other flooring and not the carpet for your robot to
Because
measure?
the carpet floor has more friction to it, so it will mess up the actual distance that it goes.
Very nice. And why did you use a 1-to-1 gear ratio? Are you geared for speed or torque or neither?
Neither, because the 1-to-1 gear ratio is key for neither.
Very good.